Good day, friends. We are back again for another WASE online experience. This is Philip, your instructor. If you are new to this channel, we will need you to subscribe for it if you've already not done that. Remember, we need your subscription for the survival of this program. To be able to do this, just go below this video and tap the subscribe button. Thank you very much for doing this. Now let's go to our activity for the day. We are still on the topic bearings and vectors. Today we'll be looking at part 4 of this topic, and under this part we'll be looking at the following. 1. Finding the magnitude and direction of vectors. 2. Addition and subtraction of vectors. 3. Multiplication and division of vectors by scalars. We will then look at zero vectors, unit vectors, and equality of vectors. I believe you are ready for this. Let's start now. We will start by looking at how to find the magnitude and direction of vectors. Now, if you have watched part 3 of bearings and vectors, then finding the magnitude and directions of vectors shouldn't be a problem. For those of us who have not done that, I'll plead with you to pay attention so you can grasp this concept well. I would still advise that you go to the part 3 and watch, because there were topics that were treated in part 3 that wouldn't be treated here. Let's start with magnitude of vectors. Let's take the vector A to be equals to x, y. Of course, the x would represent the x component of the vector A, and the y would represent the y component of this vector A. The magnitude of this vector A will be denoted by this symbol. So you have the vector A placed in between two bars. That is how I would write the magnitude of the vector A. Now, the magnitude of the vector A would be given by square root, all into brackets, the x component squared plus the y component squared, all into brackets. Let's look at examples. Example 1. We have the vector b equals to 2, 3. The x component is 2 and the y component of this vector is 3. Let's find the magnitude of the vector b. From the formula above, when you are given a vector with x and y components, all you need to do is to take the square root and take all into bracket under the square root x component square plus the y component squared, bracket closed. So that's what we are going to do. So the magnitude of the vector b will be equals to square root, all into bracket, the x component, which is 2 square, plus the y component, which is 3 squared, bracket closed. When we saw what is in the bracket, we would get 13. So we would get square root of 13 as our final answer. Example 2. Vector c equals to negative 2, then 2. So the x component of this vector is negative 2 and the y component of the vector is 2. Let's find the magnitude of C. It will be given by square root all into bracket -2 square plus 2 square, bracket closed. Let's note that the x component of the vector C is -2. So we would have to square the whole of the -2. We will not only square the 2, but the whole of the -2. That is why you have the -2 in bracket squared. When you solve what is in the bracket, you would get 8. So therefore we would get square root of 8. When you break square root of 8 down, you would get 2 root 2. If you are confused about how we got 2 root 2, then what it means is that you have not watched our video on sets, SURDS. I will therefore encourage you to look for the video and watch. Now, let's look at how we can find the directions of vectors. Directions of vectors. To find the direction of any vector, we would use the following steps. So first, we would have to represent the vector graphically. We would then use one of the trigonometry rules to find the bearing of the vector. Let's remember that bearing is direction given in angles. Let's note that the specific trigonometry rule we'll be using is the tangent rule, which is given by tan theta equals to opposite over adjacent. The acronym to help us remember this tangent rule is TOA. The T stands for tan theta, the O stands for opposite, and the A stands for adjacent. Let's look at some examples. Example 1. We have been given the vector AB equals to 4, 2, and we are to find the direction of this vector. So first, we have to draw this vector. For those of us who do not know how to do this, I would encourage us to watch the part 3 of bearings and vectors. We learned how to do this extensively. So vector AB can be represented by this diagram. To find the bearing of this vector AB, we would have to go to the north pole or the y-axis of this vector and move clockwise until we meet the vector AB. So let's do that. So this angle theta that a vector makes with the y-axis is the bearing of the vector AB. Let's find its value. To find the value of that angle, we would first need to draw a right angled triangle in that region. So let's quickly draw a right angled triangle in that region. We've been able to draw the right angled triangle, but we also need to know the part of this right angled triangle that is its opposite, and the part of this right angled triangle that is its adjacent. Remember, the opposite side of this triangle is the side that is in front of the angle theta, and the adjacent side of the triangle is the side that is beneath the angle theta. So the opposite side of the triangle will be represented by this, and its value is also 4 units, whilst the adjacent part of the triangle can be found here. Its value is also 2 units. So we have a right angled triangle with one of its internal angles to be theta. It also has the opposite side to be 4 units, then its adjacent side to be 2 units. So we are going to use the following information to look for the value of the angle theta, which also represents the bearing of the vector AB. Our tangent rule states that tan theta equals to opposite divided by adjacent. From the diagram on the screen, our opposite is 4 units and our adjacent is 2 units. So tan theta will be equals to 4 divided by 2. When you do that math, you would get 2. Theta will therefore be equals to tan inverse of 2. When you point tan inverse of 2 on your calculator, you would get 63 degrees. Remember, this 63 degrees is an answer to the nearest whole number. Also note that we are in 3 figure bearings. That's why our answer is 063 degrees. Remember, it's the same as 63 degrees. The direction of our vector AB is therefore equals to 63 degrees. Let's look at example 2. Example 2. We have been given the vector CD to be equals to 3, -5. Its x component is 3 and the y component is -5, and we are to find the direction of this vector. First, we would have to draw this vector. So we have been able to draw the vector. We need to also remember that the bearing of the vector is the angle between the vector and the North Pole, and that will be represented by this area. To get the angle of this green region, we have to know the angle between the North Pole and the East Pole. Remember that value is 90 degrees. From the y-axis to the x-axis, that angle is 90 degrees. But we have to add that value to this angle theta. So the angle theta plus 90 degrees should give us the angle of the green region, which is the bearing of the vector given to us. So our work is to find the value of the angle theta. To do this, we would first have to draw a right-angled triangle in the theta region. We would then need to identify the opposite side of this triangle and the adjacent side of the triangle. Remember, the opposite side of the triangle is the side that is facing the angle theta, and the adjacent side of this triangle is the side that is under the theta. So the opposite side will be this side. Its value is also 5 units. Let's identify the adjacent side of this triangle. This will be the adjacent side of the triangle. It's the side under the theta. Now, our tangent rule states that tan theta equals to opposite over adjacent. From the diagram, the opposite is 5 units and the adjacent is 3 units. So our tan theta will be equals to 5 divided by 3. 5 divided by 3 would give us 1.67. Theta would therefore be equals to tan inverse of 1.67. When you point this on your calculator, our theta will be 59 degrees. It is very important for us to, however, note that the 59 degrees is not the direction or the bearing of the vector CD. 59 degrees is simply the angle between the vector CD and the x-axis. To be able to find the bearing of CD, we simply have to add 90 degrees, which is the angle between the y-axis and the x-axis, to the angle theta, which is 59 degrees. So 90 plus 59 would give us 149 degrees. So our bearing is 149 degrees. Let's look at example 3. Example 3. In this example, we have been given the vector EF equals to -3, -4. And we are to determine the direction of this vector. First, we would draw this vector. So that is the diagram we can draw to represent the vector EF. The bearing of this vector is the angle between the north pole or the y-axis and the vector EF. So let's show it with this green region. Now let's show the angle between the x-axis and the vector EF. This angle is angle theta, and for us to determine its value, we would have to draw a right angle triangle in that region. Next, we would have to determine the opposite side and the adjacent side of this right angle triangle with respect to the angle theta. So that is the opposite side of the right angle triangle. This is because it is facing the theta. Its value is also 4 units. This side is the adjacent side of the right angled triangle, and it is because it is beneath the angle theta. Its value is 3 units. Now our tangent rule. It states that tan theta equals to opposite over adjacent. From the diagram, the opposite is 4 units and the adjacent is 3 units. So that will give us 4 divided by 3. And when you do the mathematics, you would get 1.33. Our theta would therefore be equals to tan inverse of 1.33. Tan inverse of 1.33 would give us 53 degrees. But let's remember that this 53 degrees represent the angle theta. It is not the bearing or the direction. The bearing is represented by the green region. So how do we find the green region? First, let's note that when we move from the north pole to the west pole, we have moved an angle of 270 degrees. So if our theta is 53 degrees. Then what it means is that to find the angle represented by the green region, we simply have to subtract the theta, which is 53 degrees, from the 270 degrees. So let's quickly do that. So we have the bearing of EF to be equals to 270 degrees minus 53 degrees. When we solve for this, we would get 217 degrees. So that is the final answer. The bearing or the direction of the vector EF. Let's look at example 4. Example 4. We are finding the direction of the vector JK, which is -7, 5. Let's first draw our vector. Let's use the green region to show the bearing of this vector or the direction of this vector. At this point, we would name the angle between the vector JK and the x-axis. We name it theta. To find the value of this angle, we would first have to draw a right-angled triangle in that region. We would now determine the opposite side and the adjacent side of this right-angled triangle. First, that is the triangle's opposite side in relation to the angle theta. Its value is 5 units, and that is its adjacent side in relation to the angle theta, and its value is 7 units. Note that the reason we are not using -7 but 7 is because the negative only tells us the direction, but we are interested in the absolute value of the 7. So the absolute value of the -7 is 7. That's what we are interested in. Our tangent rule is tan theta equals to opposite divided by adjacent. Our opposite is 5 units and our adjacent is 7 units. So our tan theta will be equals to 5 divided by 7. And when you divide 5 by 7, you would get 0.71. That is to 2 decimal places. Our theta will therefore become tan inverse of 0.71. When you punch this on your calculator, you would get 36 degrees. That is to the nearest whole number. Please note that the 36 degrees is not our final answer. It is just the theta, which is the angle between the vector JK and the x-axis. Note that when we move from the North Pole to the West Pole, we have moved an angle of 270 degrees. What this means is that to get the bearing of the vector JK, which is the green region, we have to add the 270 degrees to the angle theta. The angle theta is 36 degrees, so that will give us 270 degrees plus 36 degrees. When we do the calculation, we would get 306 degrees. So the direction of the vector JK is 306 degrees. Let's move on to something else. Let's look at addition of vectors. Let's take the vector A to be equals to xy, and let's take the vector B to be x1, y1. Now let's find vector A plus B. It will be equals to the vector A plus the vector B. That will be equals to, so what you will do is this: add the two x coordinates at the top. So let's do that. When you add the two x coordinates at the top, you would get x plus x1. Do the same for the two coordinates at the bottom, the y and the y1. When you do that, you get y plus y1. Now let's apply what we have just done in the following examples. Example 1. We have been given the vector 2, 4, and we are adding it to the vector 7, 1. So all we're going to do is to add the two x components of the vectors together. Then when we are done, we will also add the y component of the vectors together. The 2 plus the 7 would give us 9, and the 4 plus the 1 would give us 5. Example 2. We have the vector negative 7, 8 added to the vector 5, negative 3. So first add the two x components, then add the two y components. Negative 7 plus 5 is negative 2, and 8 plus negative 3 is 5. Example 3. We have vector negative 6, negative 4 plus vector 5, 10. So in this case, we would add all the x components together, then we would add all the y components together. So we have negative 6 plus 5, which would give us negative 1, and negative 4 plus 10, which would give us 6. Let's look at subtraction of vectors. Subtraction of vectors. Let's note that in subtraction, we are going to do the same thing we did in addition. The only difference is that whilst in addition we add, in subtraction we subtract. So let's look at the following. So we have the vectors A and B. Vector A is xy and vector B is x1, y1. We are to subtract vector B from vector A. So that will be equals to the vector A minus the vector B. So that will be equals to x minus x1, then y minus y1. Let's look at examples. Example 1. We have the vector 2, 4 minus the vector 7, 1. As usual, we would subtract first the x component, then we would subtract the y component. So we have 2 minus 7, that will give us negative 5, and we have 4 minus 1, that would give us 3. Example 2. we have negative 6, 8 minus 2, negative 3. So we would subtract the x component, then the y component. Negative 6 minus 2 would give us negative 8. And 8 minus negative 3 would give us 11. Example 3. We would solve the x component first, then the y component. So we have negative 2 minus 5, that would give us negative 7. And we have 14 minus 10, that will give us 4. Let's move on to multiplication of vectors by scalars. Multiplication of vectors by scalars. Let's take the vector b equals to x, y. Let's note that a scalar is just any number. It could be a fraction, it could be a whole number, it could be an integer, it could even be a decimal number. So any number that is not a vector is a scalar. Here we would assume our scalar is the letter m. We are to find m times the vector b. That will be equals to the scalar m times the vector b. That will be equals to, so this is what we are going to do. The scalar m would first multiply the x components of the vector. M times x is mx. The scalar again would multiply the y component of the vector. So here again, m times the y will be my. Let's look at a few examples. Example 1. We are multiplying the scalar 2 by the vector 3, 1. So first we would multiply the 2 by the x component, which is 3. You would again multiply the 2 by the y component, which is 1. The 2 times 3 is 6, and the 2 times 1 is 2. Example 2. In this example, we have the vector 2 over 3, 1 over 2, multiplied by the scalar negative 6. So the negative 6 would first multiply the x component of the vector 2 over 3 first. Then it will multiply the y component of the vector 1 over 2. Negative 6 times 2 over 3 would give us negative 4. And again, negative 6 times 1 over 2 would give us negative 3. Example 3. In this example, we have the scalar 3 over 7 multiplied by the vector 21, 2. First, the 3 over 7 would multiply the 21. Then the 3 over 7 would multiply the 2. 3 over 7 times 21 would give us 9, and 3 over 7 times 2 would give us 6 over 7. Let's look at division of vectors by scalars. Division of vectors by scalars. So let's say we have the vector b equals to x, y, and we have the scalar m. Let's find b divided by m, the scalar. So that will be equals to the vector b divided by the scalar m. That will be equals to the vector b. We would then change our division sign to multiplication. Then we change the scalar to its inverse. So our division sign had become multiplication, and our scalar has now become the inverse of the scalar. So we now have the vector times the inverse of the scalar. That will be equals to, at this point we already know how to multiply vectors by scalars, so we simply do that. The scalar 1 over m would first multiply the x component of the vector, and that will give us x divided by m. The scalar would again multiply the y component of the vector, and that will give us y divided by m. Now let's solve some examples with what we have just learned. Example 1. We have the vector 3, 9 divided by the scalar 3. So we would first change the division sign to multiplication, and the scalar 3 would also be changed to its inverse, which will be 1 over 3. When we do that, we would get the vector 3, 9 times the scalar 1 over 3. When the 1 over 3 multiplies 3, you would get 1, and when it multiplies 9, you would get 3. Example 2. The vector 2 over 3, 4 is divided by the scalar negative 2. First, we would have to change the division sign to multiplication. Then the negative 2 would have to convert it to its inverse form. The inverse of negative 2 is negative 1 over 2. So that would give us 2 over 3, 4 vector times negative 1 over 2. That is the scalar. So the negative 1 over 2 would first multiply the 2 over 3, and that would give us negative 1 over 3. Then it will multiply the 4, and that will give us negative 2. Example 3. We have the vector 4 over 5, 3 over 4 divided by the scalar 3 over 7. We would first convert the division sign to multiplication. Then we would rewrite the 3 over 7 to its inverse form, which is 7 over 3. So that will give us the vector 4 over 5, 3 over 4 multiplied by the scalar 7 over 3. So the scalar 7 over 3 would multiply the x component of the vector, which is 4 over 5. That will give us 28 over 15. And again it will multiply the y component, which is 3 over 4, and that will give us 7 over 4. So now let's look at zero vectors. Zero vectors. A zero vector is a vector whose magnitude is 0. The components of such a vector are also 0. For example, the vector AB equals to 0, 0. As you can see, the x component of the vector AB is 0, and its y component is also 0. So the vector AB is a zero vector. Let's calculate its magnitude and see whether its magnitude would also be 0. The magnitude of the vector AB will be given by, that will be equals to square root, then the x component square plus the y component square of the vector AB. The magnitude will be equals to square root of 0 square plus 0 square, since the x and y component of the vector AB are all 0. When you solve the items under the square root, you would get 0. So the magnitude of the vector AB would be square root of 0. Square root of 0 would also be 0. So two things are clear here. The magnitude of a 0 vector is 0, and its components, that's the x and the y components, are also zeros. So that's all you need to know about 0 vectors. Let's look at unit vectors. Unit vectors. As the name implies, this is a vector whose magnitude is 1. For example, the vector AB equals to 1, 0. Let's calculate the magnitude of this vector and see if it has a magnitude of 1. If it has a magnitude of 1, then it is a unit vector. So magnitude of vector AB would be given by this, where the symbols x and y are the x and y components of the vector AB respectively. The x component of the vector AB is 1, and the y component of the vector AB is 0. So let's substitute these numbers into the equation. So that will give us magnitude of vector AB to be equals to square root of 1 square plus 0 square. When you solve the items under the square root symbol, you would get 1. Therefore, the magnitude of AB would be equals to square root of 1. Square root of 1 would also give us 1, which means that the magnitude of vector AB is 1. Therefore, the vector AB is a unit vector. Other examples of unit vectors are vector -1, 0. You can confirm that by calculating its magnitude. Try that. Another example is 0, -1. Another example is vector 0, 1. So now that we know what unit vectors are, let's move on to equality of vectors. Equality of vectors. Two vectors are said to be equal if they have the same magnitude and direction. Let's take the two vectors A and B. Vector A is equals to xy and vector B is equals to mj. If the vector A is equals to the vector B, then we can state that A is equals to B. This means that the vector xy, which is A, would be equals to the vector mj, which is B. We can therefore make the conclusion that the x component of the two vectors A and B are the same. Therefore, x equals to m. Also, the y component of the two vectors are the same. So y is equals to j. Let's use this idea to solve a few examples. Example 1. Find the value of x if vector A and vector B are equal. From the question, we have been given the vector A to be equals to x5 and the vector B to be equals to 2, 5. And we are now being told that the vector A is equals to the vector B and that we should find the value of x. If vector A is equals to vector B, then we can state that A is equals to B. This means that our vector A, which is x5, would be equals to 2, 5, which is our vector B. So the y component of the two vectors are the same and their x components are also the same. Therefore, our x is equals to 2. Let's look at the second example. Example 2. Find the value of m and n if vector z and vector k are equal, given that vector z is equals to m plus 2, 12, and vector k is equals to 5, 7 minus n. So our vector z is equals to the vector k. This means that m plus 2, 12, which is vector z, is equals to 5, 7 minus n, which is vector k. We know that the x component of the two vectors are the same. What this means is that the m plus the 2 will be equals to 5. The y component of these two vectors are also the same. Therefore, 12 will be equals to 7 minus n. So we would use these two equations to find the value of m and n. From the first equation, m plus 2 is equals to 5. So if we want the value of m, we just move the plus 2 to the other side of the equation. That will give us m equals to 5 minus 2. When you do the calculation, the m will be 3. From the second equation, 12 is equals to 7 minus n. So we'll move the n to the left side of the equation and we'll move the 12 to the right side of the equation. When we do that, we will get n equals to 7 minus 12. So our n will be equals to negative 5. Let's look at example 3. Example 3. If 4n minus 3m equals to 2p, find the value of x given that n equals to 2x3, m equals to 1, 3, and p equals to 1, negative 2. First, let's state the formula given to us. 4n minus 3m equals to 2p. Next, we would have to substitute the information given to us into this equation. Can we do that now? So we have 4 times the vector n. Remember, the vector n is equals to 2x3. Then minus 3 times the vector m. The vector m is 1, 3, equals to the number 2 times the vector p. The vector p is 1, negative 2. So we have been able to substitute all of the vectors into the equation given to us. And now we have the scalar 4 multiplying the vector 2x3. We have the scalar negative 3 multiplying the vector 1, 3. And we also have the scalar 2 multiplying the vector 1, negative 2. We already know how to multiply scalars by vectors, so that's what we are going to do in our next step. So the scalar 4 would multiply the vector 2x3, and that will give us 8x 12. Our minus sign, the scalar 3 would now multiply the vector 1, 3, and that will give us 3, 9. Then our equal sign, the scalar 2 will now multiply the vector 1, negative 2, and that will give us 2, negative 4. At this point, we have been able to establish a vector equation. The concept of equality of vectors can also be applied here. As a result, we can derive linear equations from this vector equation. For example, the items at the top of all the vectors can give us one linear equation. So we can derive the linear equation 8x minus 3 equals to 2 from that top. From this equation, if we want the value of x, we will just need to transport the negative 3 to the right side of the equation, and we would get 8x equals to 2 plus 3. So 8x will be equals to 5. Therefore, x will be equals to 5 divided by 8. So that will be the value of our x. Let's look at example 4. Example 4. If ax plus by is equals to 2c, find the value of x and y given that the vector a is equals to 2, 3, the vector b is equals to 1, 3, and the vector c equals to 1, negative 3. So first, let's state the equation given to us. Next, let's substitute the information given to us into this equation. First, we have the vector a times the variable x plus the vector b times the variable y equals to the scalar 2 times the vector c. At this point, let's multiply our scalars by the vectors in the equation. First, the scalar x would multiply the vector 2, 3 to give us 2x, 3x. We write our plus sign. The scalar y would then multiply the vector 1, 3 to give us 1y, 3y. Remember that 1y is the same as y. Let's write our equal sign. Then the scalar 2 would multiply the vector 1, negative 3 to give us 2, negative 6. At this moment, we have our vector equation from which we can derive our linear equations. So let's see if we can get our linear equations from this vector equation. First, this will be our linear equation for the x component of the vectors. This equation is 2x plus y equals to 2. Let's name it equation 1. This will be our second linear equation from the vector equation, and it is 3x plus 3y equals to negative 6. Let's name this equation 2. So at this moment we have two equations, equation 1 and equation 2, and each of them contains the variable x and y. This is a typical example of a simultaneous equation. So we have to use the method of simultaneous equation to solve for the values of the x and y. And I must say that we have videos on simultaneous equations which you can watch if you don't know how to do simultaneous equations. It will be easier for us to use the method of elimination in simultaneous equation to solve for this. So let's use the method of elimination to do this. First, we would have to multiply the whole of the equation 1 by the number 3. When we do this, we would get this equation. How did we get this equation? Remember that we said that we are multiplying the entire equation 1 by 3. So when the 2x is multiplied by 3, we would get 6x. Let's write our plus. When our y is multiplied by 3, we would get 3y. Let's write our equal sign. And when our 2 is multiplied by 3, we would get 6. So that's how come we got that equation. 6x plus 3y equals to 6. Let's give this equation a name. We would give it equation 3. So we would rewrite the equation 3 and subtract the equation 2 from it. And remember, the reason why we are doing this is because we want to eliminate or get rid of the variable y. After all, we are using the method of elimination. So we are subtracting equation 2 from equation 3. Let's underline the two of them neatly so that we can write our answer in this box. So we have 6x minus 3x. That will give us 3x. Let's write our plus sign. We now have 3y minus 3y. That would give us 0. Let's write our equal sign. we now have 6 minus negative 6. 6 minus negative 6 would give us 12. Remember, when minus and negative meet, they will give us plus. So that will be 6 plus 6. So that will give us 12. So that is what we get after subtracting equation 2 from equation 3. We will get 3x plus 0 equals to 12. Remember that the 0 means nothing, so it is the same as 3x equals to 12. To find the value of x, we simply need to divide through the equation by 3. And when we do that, we would get x equals to 4. So we have been able to find the value of x. So all we will need to do is to substitute that value of x into equation 1 in order to find the value of y. When we do that, we would get 2x, but the x is 4, so we'll put 4 there, plus y equals to 2. From this linear equation, we can find the value of y to be equals to negative 6. So we've finally been able to determine the value of x and y using simultaneous equations. And please, for those of us who do not know how to do simultaneous equations, I would encourage you to go online and look for our series on simultaneous equations. Thank you very much. Well, friends, this brings us to the end of part 4 of bearings and vectors. You can move on to the part 5 of bearings and vectors. And under part 5, we'll be looking at the following topics. 1. Inverse vectors. 2. Parallel vectors. And 3. Perpendicular vectors. Thank you very much and stay safe. But if you have not subscribed for this channel, please go to the bottom of this video and punch the subscribe button. We'll meet again in our next video. Thank you so much.